To build the model, I'm going to take the data of is known as Boston data. It's there in the library. I think it's there in Mass library, and library tree is also to be used for decision trees. So you just run the library first, and also let's see what's there in the Boston data, just to understand what data is. So this data is about predicting house price, medial what is that okay, median value of owner occupied homes in. So this is the target variables. It's basically house price, predicting house price, and there are many factors which are responsible for house price for a particular location in the city of Boston in US. Okay, and there are many of them. Okay, I just listed out on this. This is a very popular data. You can find it on the web. So there is crime rate. There is proportion of non-retail business, then there is tax rate which also affects house price and so on. So there are so many of these factors that actually impact the house price. So in order to build the model, let's first do the sampling. So we'll have this training sample in place, and then we'll also have the test sample. So we'll first use the first take this training sample. So how do we get that? We use function sample over here, and that will give us the training sample. That would give us a way to subset the training sample. Okay, that is more appropriate to say. So once that is there, and remember we have taken 75% of the data as the training sample. Okay, so this is the syntax. So if you are not familiar with sampling syntax, so I have just highlighted it for you. Just use sample, and then take the number of rows available in Boston data, and how many of them you want. You just specify here. So I'm just taking 75%. So that's the way I have represented 75% of the data to be taken from the population data. Okay, then we'll fit the model. Okay, so we'll use the function tree, and this is target variable MEDV, so which is medium. What is that? Is median value of house price. So MEDV, and then I'll use all the factors, everything other than MEDV. So instead of writing all the factors, I just put a dot, and then it is automatically considering all the factors other than MEDV. Okay, the data set that is to be mentioned is Boston, and you are subsetting only for the training. So subset equal to train is also to be used as part of the syntax, and then we'll run this code. Now we have we have trained our model with the decision tree, and okay, have we run it? Okay, fine, yeah. So let's see what's there. Okay, so it gives you what is the root node, how many nodes are there, and you'll also get to know the threshold value used to sort of splitting the data. I was talking about splitting the data when you're using a continuous variable, a continuous factor. You're trying to split. You sort of split the data accordingly with a certain threshold, and that's what it's doing it. So we can also summarize it. We can summarize this, right? Yes. Okay, sorry. So how many variables have been used? So number of terminal nodes is 8. That's what is given to you. Terminal nodes are nothing but the nodes at the end, right? So the example that we gave, there were 4, and here it is like there are 8. You are also given the residual deviance. It's just the it's very similar to what we get mean square error, root mean square error, that kind of thing. Not exactly the same, but it's somewhat similar. So it should be as minimum as you possibly can have. And then the distribution of residual, it should always be 0. Mean should be 0. That's one of the criteria that we should look at. That should ideally be 0. Another interesting thing is that the variables actually used to tree constructions. Remember, we have used all the factors, but the algorithm uses only three. How many? Three or four? 1, 2, 3, 4, 5. Okay, only 5 of these variables have been used to build the model. I guess 6, right? Yeah, 5. So RM, LSTAT, DIS, NOx, and PT ratio. Okay, just refer to the this particular node over here, and you will understand what these variables are. Okay, so RM stands for average number of rooms per dwelling. That's obvious, that matters a lot. Lstat is what? Percentage of lowest status of the population, and so on. So there are only 5 of these variables. So 13 of them have been used in the model, but only 5 of them have been considered or considered to be very useful for the model. Okay, now once that is there, now you understood how the model, how the tree has been constructed. There are a few more things that you need to see. Okay, we learned about optimizing your tree building process, right? You may have just too many factors or too many splits in your place. So how do you know that what is the optimal? You can actually use a cross validation. That's the best way to build a tree. You can go back and forth, see what is the mean square error, test data. If it is very less, go back and rebuild the model, and just build several models, and choose the one which is giving you the least mean square error. You can do it manually. You can do step by step, write your own code which will do it for you, and you can do some sort of a repetition of that same thing over many times with different number of length of tree. Okay, and the one that gives you the least error should be chosen. But then you can also prune the tree, which is an automated way of doing it. Okay. Okay, so before that we'll also plot what we have built, right? So how do we plot it? So we just write plot, and we provide this the variable that where we have saved the summary statistics, and we also use the text and this syntax. Okay, so this is the syntax for plotting the. Alright, so this is the tree that you can look in front of me. That's exactly how we also learned in the slide for the first time. So that's exactly how you can actually beautify it. There are many packages you can use to beautify your model, because if you're using for publication and such thing, you cannot use such a picture. You rather use something fancy or something better looking. All right, the next thing to do is pruning the tree, and we'll use cv.tree function in order to prune the tree, and that's what normally is used in this case. So we'll just use the this is for cross validation. So this is cross validation dot tree, and we have provided the variable that has the summary statistics, and we can also plot it. Okay, so let's plot, and let's see at what point you have got the list or the best predictive model. Okay, best predictions. Okay, so best prediction is nothing but least deviance or least mean square error. I think it gives deviance. Yes. So in the y-axis you have got the cross-validated deviance, and in the x-axis you have got the size of the model. Okay, size means number of trees, right? Number of nodes that you have. So first, if you do the first split, you have got the highest deviance, right? So that's bad. and as you go on, it is actually going down. But many times you will see, if you go down, the deviance will go down, but it will certainly go up again. Okay, so in that case, you would be choosing the case. You would be choosing. Let me show you that is better. So many times this picture will look like something like this. Okay, so one should go in for case, the tree length exactly where the minimum is. Okay, this is like minimizing the cost function, something similar. Okay, so deviation should be the minimum. Okay. So here in this case it is constantly going down, so we'll just use 8 as our optimal sort of value. So we'll just prune the tree by taking the best as 8. So this is the syntax of pruning. So prune dot fit, I'm just assigning this variable by using prune dot tree function, and I'm providing the decision tree statistics to it, summary statistics, and also providing the number of or the length or the size of the tree that should ideally be considered as optimal. Okay, all right, now let's do that. Okay, now you can also use summary of this. Okay, true dot fit, don't change much because we have provided 8 as the terminal node, so it's going to remain same. Had it been less, looking at the diagram that I showed you, right, this diagram, had it been somewhere here, if you use 5, probably it's going to change. Okay, let's change it to 5, and let's see whether there is any change. Yeah, so you can see the number of terminal nodes is 5, so that's what you provide, right, as one of the argument when you prune your decision tree. Okay, now we can also plot it. Yes, so now it's changed, right? Previously it was much bigger, now it is much smaller, right? Whether it has actually increased your model or not, we'll just see by looking at the test error. Okay, so because this is where we only working with the training data, right? But what matters to us is the error rate in the test data, and we can use the remaining 25%, because we have taken 75% as the training data. 25% we can just take it out and use this this tree to predict data over there, and look at the test error, and then decide which one is the better, the original model or the model after pruning, or by just cutting down few of these nodes. So how do you predict? So you can use the predict function. I have shown it to in any other videos also. You can use predict function, provide the the summary statistics, and then provide the data. We are using test data, which is 25% of the data that we didn't take in the training data. So that's your test data. It's completely new. Okay, and when you run this, you will get this is the predicted value of the house prices for different observations in your data. Now using this data, you just have to compare it with the actual data. So what you need to do is that take the actual data, and this is the predicted data. You take the difference, which is the error found in each one of these observations, which could be positive or negative. uh, take the mean square error of that, square them and take the mean of that. So take the root mean square error of that and see if it has actually is actually good enough or not. Okay, and one of the important thing to note here is that you can build several of these decision trees and see which one is giving you the lowest mean square error, and that's the one to be used as the final model. Thank you so much.